Alright, looks like I'm live. Welcome back. It's been a little while, but here we are. Here we are once again with a brand new stream. First things first, let's pick some music. Let's see what we have here. I'm gonna start by genre. Maybe we can start with some background music. That's gonna go directly in my headphones. And whoop, that's a bit sad. Let's go something a bit more cheerful. Alright, that sounds good. So now the next step is to set up view, appearance, and I'm going with 125%. It should be good for any general purpose. So what are you gonna do today? Let's see, I've been messing around with the textures for some time now. And I'm gonna start a server. So first things first, we're gonna need a server to run in the background. And it doesn't have to be up to date. Well, maybe a little bit. So we have the Linux and the Windows version. Well, let's start running it first and see what happens. So this is the client at this stage. Oh yeah, right, it's not gonna run because the server is not pointing to the right IP address. And we can easily solve this. Just need to go to the client module. So let's say we're gonna have is it debug? I'm not sure. Let's see, we'll find it out. So this is not defined, it might be underscore. Okay, this one is defined. So in this case, I want it to go 192.168.1.60, which is the current machine. I'm not putting localhost because I also want to be able to connect from the Quest. So that being said, I can now rerun it, and it should wait for the server to be up before falling into the void this time. So that's a nice improvement over the last few updates. Okay, so this is the correct behavior. Now as soon as it finds... oh, okay, something weird happened. Did it just sound... what just happened? Bro, why are you not able to find the source code? We basically know where it is, but it just decided. Ah, okay. Well, let's go client 631. Which, oh, okay, well, that's disappointing. And must be in here then. Yeah, it's in host service. Send the outgoing. Oh well. Let's see if it happens again. Yeah, everything went fine up to a certain point. Disappointing. Okay, never mind. We can try again. This time the server's up, so nothing bad can happen. Okay, so with the server up, everything is fine indeed. 5,000 chunks. Why is it only 5,000? Oh, I see, because it's... no. Is it just 5,000? Oh, interesting. I thought it reached 20,000. Anyway. Receive the chunk data. Receive the request for 5,000 and then... wait, what? What? That's weird. Receive it for... oh, I see. Maybe... oh, yeah. Most of them are empty, so... this is only counting the processed ones. Oh, that's fine. It's going to be... okay. Receive the chunk data. Oh no, wait, this is in bytes. Yeah, I should put the unit. So that's not a lot of data. Okay, so it is... it's working fine. So the last time we got... let's go on the to-do list. And I'm gonna keep it on the side. So we got the maps. That's good. So the next bit that I want to add is the ability to load the texture atlas. Load texture atlas into texture. Well, that must repeat texture. So load atlas into texture array. So texture arrays are stacks of these single things, which should result in, yeah, they should result in a better behavior. Yeah, I'm even wondering if a block should, how a block should be laid out. So what would the mapping be? Do I want every face to be stacked one on top of the other? Or would I rather have a texture that is unwrapped, which might make a bit more sense, but it also duplicates the data a bit. So on one hand, we have them stacked like this. So how would I proceed? Let's try to bring that into the paint, if I can do that. Do you want to save? Ah, interesting. It's not able to load that. Okay, let's just make it bigger then. So we might end up with something like this. 1, 2. Yeah, repeating is not great. And then one from the top. And for the bottom, we might want something like this. So this would be it. And there's a lot of space that is wasted. What can we put in there? We can put variations. That could be... that could be an interesting twist. How to make a good use of the space. Again, but yeah, I could put slight variations. maybe 3 variations of the same thing. I don't know if it makes sense. Well, I might just start layering this and see if it improves without overthinking it too much. Even though right now it's kind of working. It's just missing a bit of lighting, which might improve things a little bit more. Yeah, I think I had something about the lighting. Planar occlusion. So I think this is done, kind of. Oh yeah. Let's see if the current method also solves the repeating. So we have saturate so far. We might want... So this is doing saturation. And it's going from 0 to 1. Well, actually, it's got pixel offset already in here. That might not be... what if it was from -1 to 1? Then we could do some more trickery. Yeah, let's try from -1 to 1. So we have it from -1 to 1. Then we want to bring it to +1. So that would be float 2 of 1. And then all times 0.5. Will that work? I don't know. Let's see. Okay. No, wait. What? What is the problem? Does it need to be float? Oh, it's float 2. I don't know. Would that work? No, it needs to. if I just add one? Does it understand that? Okay, that works. Okay, nice. So that works fine. And it should give back approximately the same result. Yeah, I want to start another server. Hopefully that will be compatible. I don't think I have changed much recently on the server side. Okay, it's working. And we are back. Huh. To a nice solution, okay? I don't see any artifact. It's pretty clean. Okay, it's nice and clean. Well, maybe just a slight. Just a tiny bit. It's leaking. Oh, I need to get rid of this issue. Capture. Oh, the capture client. Okay, capture client. I think I did not stop the capture. In the client. Call back. Did I not stop the unclosed? Stop. Well, it should stop. Yeah, I don't know what's going on here. Unclosed. Maybe it's not closed. The microphone track. Oh yeah, that is closed. Clean up. Is cleanup ever called though? Destroy system. Well, cleanup it's not called. Yeah, let's do a cleanup. And hopefully that should fix the annoying. Okay. Same as before. Close it. Ah, nice. It's as clean as it can get. So back to the shader. Now that we have saturate. Or maybe instead of saturate, you can get a fractional part. Let's see. Okay, we have saturate. Frac? Is it frac or fract? Okay, frac. Frac should be the one. Let's say frac actually behaves the same way. It kind of does. Even though it creates a bit of a seam. So times 0.5 times 2. This should make it okay, much denser. Oh, that's nice. Looking fabulous. Well, not quite, but oh, okay, not. It's not super great though. So maybe we still want the saturate here. Clean. Yeah. Well, clean. It's cleaner. Not the cleanest though. Let's saturate again. I don't know, this is a good idea. No, it's not working anymore. The trick has been busted. Yeah. It's not very nice tiling. Well, mostly that's because this is a single phase, but then it would end up the same. Okay. Yeah, this is not really working as intended. So I would say we need to go through the Atlas way. I want to preserve the loading of the textures just because this is good. Maybe the option to generate the MIPs would be nice, but you can always remove functionality. After they've been added. So the easiest thing would be to just clone. Yeah, let's clone the whole function. Or maybe break it down. No, that wouldn't work. This is very specific. And it's going to be load atlas. Pretty much the same signature. Okay, I read the texture now. I want to split the texture into bits. And I would say we need a couple of parameters. Yeah. An IVEC 2. I don't know why I prefer const to be first. And that would be the grid size. What? No, what did I just do? I can reset. Okay. Slow this big boy. And the alpha. Okay, the MIP levels. How do I do the MIP levels? Yeah, everything. RGB. So it's not going to be a span of data. It needs to be split into parts. I guess that's the first thing to do. Split the grid. Oh, split the grid. That should be self-explanatory. So the grid size. What's the grid size? Okay, this is a tricky bit. The grid size is divided in rows, which are x. Is it from up to bottom? 0, 0 is going to be up. That's because the UVs goes this way. Okay. Oh, something like this. This is going to be 0. This is 1. 2. Okay. And so on and so forth. So this is a row. And row. The grid size is unsigned, of course. Can't be negative. Grid size dot y. That's the row. And same for the column. Good guess. So now we need a vector. We don't have vector. A vector of vectors. Of just 8. Oh, we don't have vectors. Yeah. Include vector. Okay. And cells. Let's call them cells. Damn, what is it called? So I'm gonna call them cells. And so at this point we need this line by line. Yeah, we need to copy line by line. And the cell. So this is a grid size. We need the cell size. It's going to be a const glm uvec2 cell size. Which is the texture size divided by the grid size. Somehow it should, and hopefully it's a good number. Yeah. Okay. I'm just gonna leave a note here. Note. Check if grid size. Yeah, you don't want to you don't want to have reminders and things like that. That would be nasty. Okay, so now that we have the cell size, we just need to go over y, and that's the cell size, correct? Now we need a source pointer. It's going to be uint 8 pointer, which is a source line that is row times width so this is the current row. I do row by row, is it correct? And the offset is going to be the column. Yeah. So the start of a row, and then that's the column. Okay. That should be good. Just pointer, which is rgb.data plus now.get. Okay. That could be correct. And this is going to be const. And then we have and AT star destination line. Destination lie. Which is, oh wait, we need to make a cell. So have cells that in place, and that is auto reference cell, and then cell will resize to cell. Wait. And in all of this, what we need to do is to multiply by the number of channels. Yeah, let's not forget that. Row weight times channels times, you can guess it. No? Okay. Channels. All right, last step is to get the cell.data plus y no, it doesn't have column, but it's cell size. Oops, typo. Cell size.x. Okay. Then stood copy source. So that would be source. channel is correct, but it's going to be cell size.x times channel. Okay. And after we have done with the cell, we can even dump the cell plus TBI. We don't have implementation for include image right. Okay. It's TB image right PNG. Do we have the header? Oh, here it is. Oh wait. Oh, it added it. Okay, I just added it. So that the name. What would the name be? I'll say std string. Name is going to be cell PNG std format. See a std format which we don't have. Can you add it? Bro. And row column. There you go. So name.cString. The width is cell size dot x and cell size dot y. Components is the number of channels, and the data is a cell dot data. Wait, that's not correct. And the stride. Well, I think you have everything that you needed. Can be 0. I think the stride can be 0. What? Oh. No, we need to find this guy. Where's the documentation bit? Oh well. Never mind. You were not able to help me. Yeah, wait for the context. Come on. Just include format. It's not that hard. What's up with this? Copy can be replaced with a call to copy n. And I would say this can be done. We just need to see if it works. Well, let's see if it compiles first. And while it's at it, I'm gonna do the same here. So first, first thing, load Atlas. What's wrong? Oh yeah, it requires size, which is 2 times 4. 4 rows, which is Y. Okay. What's wrong with it? Unresolved. Bro. STP. Oh, maybe. Maybe it needs right. Okay, yeah. All right. No problemo. No problem. You can do that. Let's come over here and see the magic. Let's see the magic happening or failing. Okay. Oh, it's not failing. That's nice. There you go. Look at that. Okay. Yeah, it's correct. It's well, this sucks. 0, 1, 0, 0 was correct, I think. Let me open them. Here. Oh. Ouch. Well, not really correct. So this this is how it should look like. 0, 0, it's not like that. Where is 0, 0? Ouch. 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 Ah. Okay, well, that was close. That was close. I'll be back in a couple of minutes. So it should work now. I just missed a bunch of bunch of things. I needed the offset across the whole line size and in different ways. Okay, so at this point I would expect this to update. Discarding return value to update into a nice texture, but it's not updating. Okay, it updated. Nice. Okay, good. This is actually the correct result. So now that we have them split into single textures, let me check if the order is correct. Yes, 1, 2, 3, 4, 5, 6, and then 2 transparent ones. Okie dokie. So we have a correct separation of them now. Now we need to create the image. And the according MIP levels. But the MIP levels this time will be on the grid, on the cell size .x cell size .y. I kind of feel like this is a very small texture. Such a waste creating MIP levels for this. Okay, one step at a time. So the number of layers will be cells.size. And I guess we're gonna need to have them constant 32 layers. Oh hey, Gandav. Alright, once we have the layers, everything is going to be pretty much the same. Except for me specifying which layer I'm working on. I've got multi-draw indirect and bilendless texture engine now. Time to implement meshlets. Oh, that's a very nice news. And I've got voice chat. And another few things working. I don't know if I have a working example right now. I always do the performance thing. You never know. Hardware can be a bit funny sometimes. MIP levels. So I fixed a bunch of things. Well, first of all, you can finally resize the window. And there are still visible seams that I need to resolve at some point. But overall, it looks a bit nicer now, even though the repetition makes it a bit ugly, but that can be fixed with a bit of more artistic touch. I just care about that's a big building that my son made. Is it missing something? Oh, okay, yeah, because this is using an older database. Now you can't even tell if there are windows. So I really have to implement some sort of ambient occlusion or lighting, because this is getting boring now. Now that the seams are not there anymore, they all kind of mush together. At least the seams gave it a bit of a wireframe look. And the distance draw is pretty far, so even on the Quest, it can easily render this distance. But I still employ some of cool techniques that I've seen around. Like one of these is, I think this is a very nice idea. So having LODs on the chunks. I think there was a picture. So the seams are a bit of a nightmare. So there are many reasons for having the seams, and first is the tile map. So tiles will always have seams unless you give them a little bit of padding, and that's due to interpolation. And another problem is also MSAA. So the multi-sampled anti-aliasing, that will go and sample regions around your texture, especially when you're drawing here. It kind of shoots outside of the boundary of your geometry, and so if you think about the interpolators, they will interpolate beyond the 1.0. and so that's why it's going to go in other places. So the way that I resolved it is just saturating in the pixel shader. So just saturate the hell out of it, and yeah, this was unnecessary. But this also gives me the ability to tile. So I don't think this current scene is tiled, but for each block. Oh yeah, it is actually. So for each block, it is drawn 4 times. 2 times for each direction. But then there are still these very odd seams, so they're not tiling nicely. Yeah, it's still there. So the way that I want to solve it now is to use layered textures, and that would make things a bit easier. So the layered texture is going to be made out of single cells, and this shouldn't have any issue with going out of the bounds, because there are no bounds. But this also, it's a bit of a limitation. So it's so the limitation is on the hardware level. So I don't know what's the limit of the number of layers, but it can be somewhere around 2 or 4K, which is okay for my purpose right now. But it's, yeah, texture layers, texture arrays, same thing. They're called layers or arrays. They're called both array layers. So yeah, that's the one. So I just finished doing, yesterday I finished the implementation for the MIP maps generation, and now that didn't really help much, I would say, but it's probably needed anyway. So now I'm gonna have to deal with the texture arrays and the MIP maps. I'm not even sure MIP maps are worth. Like, this is a 16 by 16. Anyway, I don't know. It's not a lot of code anyway, so I might just do it. It's one more loop, a third dimension. So let's go about it. Yeah, bindless textures. Yeah, I don't know about bindless textures. So there's probably there is probably an extension, I guess. Yeah, I don't think it's descriptor indexing. Is it just descriptor indexing? Oh, okay, well, it's not. Yeah, but it's still. I mean, it's still the same, and I think indexing is still more expensive than just having a single binding. I don't think indexing is going to be much more performant than a single bind. can make a massive array descriptors to texture. New descriptor indexing extension you don't have. Yeah, but still, you can stream texture. But still, I mean, single texture would be much more performant. Yeah, that's a pretty good deal. I mean, it's a very small texture anyway. It's 16 by 16 by 1024 for the whole world. That is more than enough. Yeah, my only worry is that at some point there will be variations of these, and not handmade variations, but more like how do you say? Yeah, more like procedural variations. So mixing things up and having additions to layers to a material. But yeah, I don't want to worry about that right now. So that would be one step at a time, which is the whole philosophy of this project. Tiny steps. Yeah, but the problem is efficiency. So you, how would you, for example, index from one block to the next one in a single draw call? How would you do that? That's the challenge, right? Because these are all drawn in the same. These are drawn all in the same, like it's 32 by 32 by 32 blocks, all drawn at the same time. And indexing, yeah, I don't think you can do that. But you can easily change the UVs. That's very simple to do. So I think UV indexing is much simpler than descriptor indexing for this type of rendering, at least. I guess there is a place for indexing too. Yeah, but still, how would you address different textures within the same? Yeah, I guess it's a completely different way of rendering anyway. So right now I'm using vertex attributes, which and the way you're describing it, it's yeah, vertex pooling and buffer devices addresses are probably more suitable for that kind of rendering. Oh, okay. Yeah. It looks reasonable. I guess I will have to explore a bit more. So I'm gonna be back to these layers. So that's the image. We allocate the image. Does the image view not care about? Oh, here's the layers, I think. Oh, that's the layer count. Okay, so this is the image view. Okay, there's a bit of a difference here. So the width and the height are not for the whole image anymore. Cell size. Okay, staging buffer. Yeah, that should equal. That should be alright. And we generate the MIPS later. I guess I have to give bindless a look and see what is the what's the actual implementation looks like on the Quest. So we do the copy. Okay, copy into the staging buffer. Oh wait. So I don't have to split them here. Oh, I didn't have to split them here. Damn. But wait. So can I copy a region of the buffer? Well, the simplest thing would be to create multiple staging buffers. So buffer to image. Buffer row length, okay. Buffer image height. And then the offset. Offset and extend. I should be able to do that. So, okay, so this was a waste of time. Well, I'm gonna comment it out. Oops, wrong keystroke. Yeah, I didn't have the full picture at this stage. Okay, so the number of of layers would be grid size dot x times grid size dot y, and that's already U32. Okay, so same allocation, but now we need multiple copies. Okay, it's actually much simpler now. So we can keep the same structure. We're gonna have a vector of copies. Okay, so auto copy. Oh, I don't need to save this. That would be enough. Does HLSL have combined image samplers? Last I heard, didn't. That's what made me decide to use slang instead. Yeah, I think it does. So I'm using that. So textured should have it. Yep. So that's it. And in the texture, it still appears like separated, but they both bind to the same location, so they are the same thing. We can reserve, as we already know, the layer size, layers. Yeah, there are some trickeries, like for example, in the rendering of this thing, I had yeah, it's this guy here. The view index, for example, this also needs, yes, the draw index. Oh yeah, the draw index, I had to make it go through instance ID. Otherwise, it gives me compilation error, which is a bit odd. There are some tricks to make everything work, but the good thing is that I can have a header file which is still slightly more compatible with C++. and then I can just include it here, given that I disabled some of the keywords like disable C buffer and all the weird keywords, keywords that don't make sense in C. So the buffer row is going to be width, the buffer image height. Is this the full height? Buffer image height, I guess so. Okay, so the offset is going to be image offset. Wait, is this all? The buffer to image. This doesn't seem like it's gonna give me the ability to only copy a region of the buffer. This one's to copy the whole buffer, because there's no offset in the buffer. Yeah, this is a scam. Let's see if there's a different... Buffer to image 2, maybe. VK copy buffer to image info. VK copy buffer to image. Okay, this one. That's the source buffer. Okay, that's the region. Oh, that's the buffer offset. Not very useful. No, I don't think this can do it. Yeah, but that's this isn't right. It's not. It doesn't allow me to copy a region inside the buffer. So technically, this isn't very useful. So it only allows me to copy the whole buffer into a specific region. So the opposite, basically. It allows me to create an atlas but not to break it down. Okay, so let's go back to the old way. I'm glad it's still here. So that is pretty much... Now that's completely different, because I will need I would need multiple staging buffers. That would be the easiest to do. No, I don't think I can do so. I need to copy the whole buffer, which represents the atlas, into a single layer. And as you can see here, there is the buffer whole like image size, which I think you have to specify, because otherwise that's just a linear buffer. And you may be talking about image to image, but this is buffer to image. And you get the buffer row, the buffer height, which is a usual representation of a buffer. But then you only have the image offset and the image extent. So there is nothing about the offset in the buffer. And specifically jumping from, so this is going to copy a contiguous buffer, and being inside here, so let's say I want to copy this region. I wouldn't be able to do that because it would copy this whole line and just keeps going. So it can't jump from this line to this line and do it again and skip this whole bit. Yeah, I don't really see how you can do that anyway, because there is nothing specifying the size of, because yeah, that's the offset on the image. There is no offset on the buffer. Like, how would you know on which part of the buffer? I don't think so. You're saying that this gives for granted that your buffer size matches the image size, which shouldn't be, because this the cell that I want to copy, it's smaller than the original size, so it doesn't know what is the original size, and it can't really say that the offset will be 0 and the extent will be the full size. Yeah, but still, it needs to jump over. So there is a buffer offset, but then it's gonna read it contiguously from that buffer offset. There's no buffer 3D offset. Let's see. Not a region. A sub-region. So the buffer offset, okay. The length in textile of the buffer, the image height of the buffer, setting them to 0 is typically when the buffer data is tightly packed no padding. The image offset. The image. Okay, that's the region to copy. Okay, but Atlas image. Cell location in Atlas, XY. Okay, so that's the buffer offset, okay. Quite tricky. Okay, let's see. But can I do the two? Because the one doesn't have an offset. Oh no, this. Oh no, wait. It also has an offset. Okay. And so the offset would be. And I also need to specify the sizes because this is a suballocation of inside another buffer, so I'll have to tell it how big it is. So the so I'm gonna need to compute that. Which is kind of like this. A source line. What? No. Ah, come on. Okay, so the source line. Oh, I got rid of an essential bit. Except for this one, okay. So this would become source line offset. And it's VK device size. Okay, that should be it. The offset is 0. And the extent... Oh wait, the offset... So the offset in the image, that would be the layer. And the layer index gonna be row times grid size dot x and column. Okay, so that will be the layer index. What's wrong with it? You don't like it because it's int. Okay. And the image extent is going to be so we have already the cell size.x and the cell size.y. Stream is not working. Sure. Looks good to me. Looks. It's looking good. Okay. Yeah. Yeah, I'm also co-streaming on Twitch, so I was getting a message from Twitch. Let's make this const. And that's about it. So at this point we would have the image ready. I might just comment this out. Not gonna use it right away. Just wanna see how it looks in RenderDoc. Ooh, it's running, that's why. Oh, that's small. Is he even gonna run? Wait, what? I didn't like it. So what's wrong with it? Width, height times 4. What's wrong with it? There should be nothing weird so far. Oh wait, oh yeah, of course. Of course. Doing something dumb. Buffers are not initialized at this stage. Create shaders, create resources. Create buffers. Yep. Classic. Wait. I think I need to do one capture at least. And ref all resources. That should be enough. Let's do one capture. And resources. Does it have a name? Why is it so small? I can barely see what's going on. Should I have given it a name? Yeah, I have no idea which one is descriptor sets. What's the default name? Memory? It's not the memory. 2D image. Oh, there you go. They are probably in the order of creation or something. No, it's 2D. Okay. But that's very empty. That's very. But there are 7 of them with MIPS. Oh, it even generated the MIPS the wrong way. Okay, the MIPS are definitely wrong. The MIPS are wrong and they shouldn't be generated. Right. Wait. I forgot. This one. Okay, aspect is the color. Then the MIP level is 0. The base layer is going to be the layer index. Ah, I see. That's where the layer is. Wait, what is this offset then? That's gonna be 0 then. Oh, come on, now you want your int. So that's the layer, base layer, and layer count is 1. I don't know about the offset though. Image offset. It says 0. And this one, okay. Okay. Not quite my tempo. 16 by 16 is correct. But yeah, this is it's a bit weird. But it is something. So 0, 0, and there are 8. That is correct. Okay, the MIPS don't contain anything, that's correct too. But the slices are wrong. So the slices are wrong, but in a sense it's working. So that's already a win. I'm sure I'll figure this out soon. For now, I'm gonna stop the stream, and yeah, that's a good progress so far. And I'll see you in the next one. See you again. Have a good day or night, I don't remember.